Question 1. The efficiency study reveals a significant increase in call drop rates and a degradation in voice quality for users connected to the Cisco Unified Communications Manager (CUCM) cluster. Network engineers are investigating the issue and considering several approaches to restore optimal performance. Which of the following approaches best aligns with maintaining reliable IP telephony services and adhering to best practices for network management? Option A. Focus exclusively on upgrading the CUCM server hardware and software without examining the underlying network infrastructure. Option B. Implement quality of service (QoS) policies on network devices to prioritize voice traffic, ensuring it receives sufficient bandwidth and low latency. Option C. Increase the overall network bandwidth across all segments of the network indiscriminately to alleviate potential congestion. Option D. Disable quality of service (QoS) configurations on all network devices to simplify troubleshooting and observe any immediate changes. The correct answer is B. Implement quality of service (QoS) policies on network devices to prioritize voice traffic, ensuring it receives sufficient bandwidth and low latency. Explanation. The efficiency study reveals a significant increase in call drop rates and a degradation in voice quality for users connected to the Cisco Unified Communications Manager (CUCM) cluster. This scenario is professionally challenging because it directly impacts the core functionality of the IP telephony system, affecting user productivity and potentially business operations. The challenge lies in identifying the root cause within a complex network environment and implementing a solution that adheres to Cisco's best practices and relevant regulatory guidelines for telecommunications services, without introducing new issues or violating compliance. The correct approach involves a systematic troubleshooting methodology that prioritizes network stability and adherence to established quality of service (QoS) policies. This aligns with the principles of maintaining reliable communication services, which is implicitly expected by regulatory bodies overseeing telecommunications. Specifically, ensuring that voice traffic is prioritized and receives adequate bandwidth through proper QoS configuration on network devices, including the CUCM cluster and the underlying IP network, is paramount. This proactive and structured approach minimizes disruption, ensures service continuity, and upholds the expected quality of service for voice communications, reflecting best professional practice in network management and telecommunications. An incorrect approach would be to immediately implement broad network changes without a clear understanding of the impact on voice traffic. For instance, indiscriminately increasing bandwidth allocation across all network segments without considering the specific needs of voice traffic could lead to congestion for other critical applications and may not resolve the voice quality issues. This approach fails to demonstrate due diligence and a systematic troubleshooting process, potentially leading to further service degradation and non-compliance with service-level agreements. Another incorrect approach would be to focus solely on the CUCM server resources without examining the network path. Server performance is important. Voice quality issues are frequently network-related. Ignoring network factors like packet loss, jitter, and latency, which are critical for real-time voice traffic, represents a failure to address the most probable causes of call drops and poor voice quality. This oversight can lead to prolonged downtime and a failure to meet the expected standards of a telecommunications service. A third incorrect approach might be to disable QoS entirely to see if it helps. This is a highly risky and unprofessional action. QoS is specifically designed to manage and prioritize real-time traffic like voice, and its absence would almost certainly exacerbate the problem by allowing less critical data traffic to consume the bandwidth needed for voice, leading to increased packet loss and jitter. This action demonstrates a lack of understanding of fundamental network traffic management principles and a disregard for maintaining service quality. A professional decision-making process for similar situations should involve a structured troubleshooting framework. This begins with clearly defining the problem and its scope. Next, gather relevant data, including network monitoring tools, CUCM logs, and user feedback. Formulate hypotheses about potential causes, prioritizing those related to network performance and QoS. Test these hypotheses systematically, starting with the most likely causes. Implement changes incrementally and monitor their impact. Always refer to Cisco's recommended best practices and any applicable regulatory guidelines for telecommunications service providers to ensure compliance and maintain service integrity. Question 2. Investigation of the implementation of a new IP telephony system within a U.S.-based financial services organization raises concerns regarding the recording of client calls. The organization must ensure that its call recording practices comply with all applicable U.S. federal and state laws, particularly concerning consent and data privacy, before the system is fully deployed. Which of the following approaches best ensures regulatory compliance and ethical data handling? Option A. Conduct a thorough review of all relevant U.S. federal and state telecommunications and privacy laws, consult with legal counsel specializing in these areas, and implement a clear, informed consent mechanism for all parties before enabling call recording. Option B. Rely solely on the IP telephony vendor's documentation, which states that their system is compliant with general data protection principles, and proceed with deployment without further legal consultation. Option C. Enable call recording by default for all calls, and provide a general disclaimer on the company website regarding call recording, without obtaining specific consent for each interaction. Option D. Proceed with the IP telephony system deployment, assuming that standard industry practices for call recording are sufficient and that client consent is implicitly granted by continuing the call. The correct answer is D. Proceed with the IP telephony system deployment, assuming that standard industry practices for call recording are sufficient and that client consent is implicitly granted by continuing the call. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent tension between implementing new technology for enhanced communication and ensuring compliance with established regulatory frameworks governing telecommunications and data privacy. The need to integrate a new IP telephony system requires careful consideration of how existing regulations apply to this evolving technology, particularly concerning call recording, data storage, and user consent. Professionals must navigate potential ambiguities in regulations when applied to IP-based systems, demanding a thorough understanding of both the technology and the legal landscape. Correct approach analysis. The correct approach involves a proactive and comprehensive review of relevant U.S. federal and state regulations pertaining to telecommunications, data privacy, and consent for call recording. This includes, but is not limited to, the Communications Act of 1934, the Electronic Communications Privacy Act, ECPA, and relevant state-specific privacy laws. The process should involve consulting legal counsel specializing in telecommunications law to interpret these regulations in the context of IP telephony, implementing the system only after obtaining explicit, informed consent from all parties involved in calls, and ensuring that data storage and access adhere to privacy standards represents best professional practice. This aligns with the ethical imperative to protect user privacy and comply with legal obligations, thereby mitigating risks of litigation, fines, and reputational damage. Incorrect approaches analysis. Implementing the IP telephony system without first verifying its compliance with U.S. federal and state regulations regarding call recording and data privacy is a significant regulatory and ethical failure. This approach demonstrates a disregard for legal obligations and user rights. Specifically, failing to obtain informed consent for call recording violates privacy laws and can lead to severe legal repercussions. Storing call recordings without adequate security measures or clear retention policies exposes sensitive data to breaches, violating data protection principles and potentially specific statutes like the California Consumer Privacy Act, CCPA, if applicable. Relying solely on the vendor's assurances without independent legal verification is also a failure, as vendors may not fully grasp the nuances of a specific organization's regulatory environment or may prioritize sales over comprehensive compliance. Professional reasoning. Professionals faced with implementing new telecommunications technologies should adopt a risk-based, compliance-first approach. This involves 1. Identifying all applicable regulatory frameworks, federal, state, and local, relevant to the technology and its intended use. 2. Engaging legal counsel to interpret these regulations and provide guidance on implementation. 3. Conducting a thorough risk assessment to identify potential compliance gaps and privacy concerns. 4. Developing and implementing clear policies and procedures for the technology's use, including consent mechanisms, data handling, and security protocols. 5. Regularly reviewing and updating compliance measures as regulations evolve or technology changes. This systematic process ensures that technological advancements are integrated responsibly and ethically, safeguarding both the organization and its users. Question 3. What factors determine the appropriate configuration of Cisco Unified Communications Manager (CUCM) features to ensure compliance with U.S. federal regulations regarding lawful intercept capabilities for telecommunications service providers? Option A. The preferences of end users for specific call handling features, which are important for user adoption, but are unrelated to the legal obligations for lawful intercept. Option B. The internal IT security policies of the organization, which may impose stricter security measures than legally required, but do not necessarily address the specific technical mandates for lawful intercept. Option C. The bandwidth availability and network latency of the enterprise network, which are critical for call quality, but do not directly dictate the technical implementation of lawful intercept features. Option D. The specific requirements outlined by the Communications Assistance for Law Enforcement Act, CALIA, and relevant Federal Communications Commission, FCC, rulings, which dictate the technical capabilities and operational procedures necessary for law enforcement access to telecommunications content and metadata. The correct answer is D. The specific requirements outlined by the Communications Assistance for Law Enforcement Act, CALIA, and relevant Federal Communications Commission, FCC, rulings, which dictate the technical capabilities and operational procedures necessary for law enforcement access to telecommunications content and metadata. Explanation. The implementation of IP telephony and video solutions within an enterprise environment, particularly concerning regulatory compliance, presents a significant professional challenge. The core difficulty lies in balancing the technical requirements of deploying and managing these systems with the stringent legal and regulatory obligations that govern data privacy, security, and telecommunications services. Professionals must navigate a complex landscape where technical decisions have direct implications for compliance, and failure to do so can result in severe penalties, reputational damage, and loss of customer trust. Careful judgment is required to ensure that all deployed solutions adhere to the applicable regulatory framework without compromising functionality or user experience. The correct approach emphasizes a proactive and integrated strategy for regulatory compliance. This involves understanding the specific regulatory requirements applicable to the jurisdiction in which the organization operates, such as those pertaining to data retention, lawful intercept, and the privacy of communications. By embedding compliance considerations into the design and implementation phases, organizations can build systems that are inherently compliant, rather than attempting to retrofit solutions later. This approach represents best professional practice because it aligns with the principles of privacy by design and security by design, which are increasingly mandated or strongly recommended by regulatory bodies. Specifically, in the context of the U.S. regulatory framework, this would involve adherence to regulations like the Communications Assistance for Law Enforcement Act, CALIA, for lawful intercept capabilities, and the Children's Online Privacy Protection Act, COPPA, if the services might be used by children, alongside general data protection principles found in various state and federal laws. An incorrect approach that focuses solely on technical performance without considering regulatory implications is professionally unacceptable. This failure stems from a disregard for legal obligations, leading to potential violations of data privacy laws, such as the Health Insurance Portability and Accountability Act, HIPAA, if patient data is transmitted, or the General Data Protection Regulation, GDPR, if EU citizen data is involved, even if the primary jurisdiction is U.S. Such an approach creates significant legal and ethical risks. Another incorrect approach that prioritizes cost savings over compliance is equally problematic. While budget constraints are a reality, they do not excuse non-compliance. Regulatory requirements are not optional, they are legal mandates. Ignoring them for financial reasons can lead to far greater costs in the form of fines, legal fees, and remediation efforts. This demonstrates a lack of professional responsibility and an understanding of the long-term implications of regulatory noncompliance. The professional decision-making process for similar situations should involve a thorough risk assessment that explicitly includes regulatory compliance as a key factor. This means identifying all relevant regulations, understanding their impact on the IP telephony and video solution, and integrating compliance requirements into the project plan from the outset. Collaboration with legal counsel and compliance officers is essential to ensure accurate interpretation and implementation of regulatory mandates. Furthermore, continuous monitoring and auditing of the deployed systems are necessary to maintain compliance as regulations evolve and the technology landscape changes. Question 4. When evaluating the security posture of a new IP telephony deployment connecting multiple remote branch offices, which risk assessment approach best ensures compliance and operational resilience? Option A. Prioritizing the lowest cost security solutions for remote sites to manage implementation expenses, with a focus on basic network protection. Option B. Forming a high-level risk assessment that focuses primarily on the central data center and assumes remote sites have minimal security requirements. Option C. Relying on the existing security policies and infrastructure of the central headquarters to cover all remote locations, assuming similar threat landscapes. Option D. Conducting a thorough risk assessment that analyzes threats specific to remote site connectivity, including network vulnerabilities, access controls, and the impact of environmental factors on service availability, and developing tailored mitigation strategies. The correct answer is D. Conducting a thorough risk assessment that analyzes threats specific to remote site connectivity, including network vulnerabilities, access controls, and the impact of environmental factors on service availability, and developing tailored mitigation strategies. Explanation. When evaluating the implementation of Cisco IP telephony and video solutions, a critical aspect is the proactive identification and mitigation of potential risks. This scenario presents a challenge because the organization is expanding its IP telephony infrastructure to include remote branch offices, introducing new attack vectors and complexities in network security and service availability. The professional challenge lies in balancing the benefits of enhanced communication and collaboration with the inherent security and operational risks associated with a distributed IP-based system. Careful judgment is required to ensure that the deployment adheres to best practices and regulatory requirements without compromising business continuity or data integrity. The correct approach involves conducting a comprehensive risk assessment that specifically considers the unique vulnerabilities introduced by remote site connectivity, such as increased exposure to network-based threats, potential for unauthorized access to voice traffic, and the impact of network latency or instability on call quality and availability. This assessment should identify potential threats, analyze their likelihood and impact, and define appropriate control measures. This aligns with general IT security best practices and, in the context of regulated industries, would be a prerequisite for compliance with data protection and business continuity regulations. For example, in the U.S., regulations like HIPAA for healthcare or SOX for financial services implicitly require such risk assessments to ensure the confidentiality, integrity, and availability of sensitive information, including voice communications. An incorrect approach would be to assume that existing security measures for the central office are sufficient for remote sites. This fails to acknowledge the expanded attack surface and the unique environmental factors at remote locations, potentially leading to regulatory noncompliance if data breaches or service disruptions occur. Another incorrect approach is to prioritize cost savings over security by implementing minimal security controls at remote sites. This is professionally unacceptable, as it directly contravenes the principle of due diligence in protecting organizational assets and sensitive communications, and could result in significant financial penalties and reputational damage if security incidents arise. Furthermore, neglecting to involve remote site IT personnel in the risk assessment process is a failure in collaborative risk management, potentially overlooking critical local environmental factors and operational realities, which can lead to ineffective security controls and non-compliance with operational resilience requirements. The professional decision-making process for similar situations should involve a structured risk management framework. This begins with defining the scope of the assessment, identifying all assets and potential threats relevant to the IP telephony deployment, especially at remote locations. Next, analyze the likelihood and impact of identified risks, prioritizing those with the highest potential for harm. Subsequently, develop and implement appropriate mitigation strategies, which may include technical controls, e.g., VPN, firewalls, encryption, administrative controls, e.g., access policies, training, and physical security measures. Finally, establish a process for ongoing monitoring, review, and adaptation of the risk assessment and mitigation strategies as the environment evolves. Question 5. The audit findings indicate that the recent implementation of Cisco IP telephony and video solutions has not undergone a thorough risk assessment process that adequately addresses potential threats to service availability and data privacy within the U.S. regulatory framework. Which of the following approaches best mitigates these identified audit findings? Option A. Implement a robust business continuity plan that includes redundant network paths and backup power for all voice and video endpoints to ensure service availability. Option B. Conduct a comprehensive risk assessment that identifies potential technical vulnerabilities, operational impacts, and compliance requirements specific to U.S. telecommunications regulations, and develop mitigation strategies accordingly. Option C. Review and update the organization's acceptable use policy for IP telephony and video services to clearly define user responsibilities and prohibited activities. Option D. Focus on reconfiguring the Cisco Unified Communications Manager to harden security settings and ensure all voice and video traffic is encrypted, as this directly addresses technical vulnerabilities. The correct answer is B. Conduct a comprehensive risk assessment that identifies potential technical vulnerabilities, operational impacts, and compliance requirements specific to U.S. telecommunications regulations, and develop mitigation strategies accordingly. Explanation: the audit findings indicate a potential gap in the organization's risk assessment process related to the implementation of Cisco IP telephony and video solutions. This scenario is professionally challenging because a robust risk assessment is fundamental to ensuring the security, reliability, and compliance of any IT infrastructure, especially one as critical as a unified communication system. The challenge lies in identifying and prioritizing risks that could impact business operations, data privacy, and regulatory adherence, while also considering the specific technical nuances of IP telephony. The correct approach, which involves a comprehensive risk assessment that considers technical vulnerabilities, operational impacts, and regulatory compliance specific to the U.S. telecommunications landscape, represents best professional practice. This aligns with the principles of due diligence and responsible IT management. Specifically, it addresses the need to identify potential threats to the confidentiality, integrity, and availability of voice and video communications, which are often subject to regulations like HIPAA for healthcare communications or FCC rules for telecommunications services. A thorough assessment ensures that mitigation strategies are proportionate to the identified risks and that the implementation adheres to established security frameworks and legal requirements. An incorrect approach would be to focus solely on the technical configuration of the Cisco devices, without considering the broader operational and regulatory context. For instance, merely checking if ports are open or closed without understanding the implications for data exfiltration or unauthorized access to sensitive call data would be a failure. Another incorrect approach would be to ignore potential compliance issues, such as ensuring that call recording mechanisms meet legal requirements for consent or data retention, or failing to assess the risk of service disruption to critical business functions. These failures represent regulatory and ethical shortcomings because they neglect the organization's responsibility to protect sensitive communications, maintain service continuity, and comply with applicable U.S. laws and industry standards governing telecommunications and data privacy. Professionals should employ a decision-making framework that begins with understanding the scope of the IP telephony and video implementation and its criticality to business operations. This should be followed by identifying potential threats and vulnerabilities across technical, operational, and compliance domains. Subsequently, the likelihood and impact of these risks should be assessed to prioritize mitigation efforts. The process must be iterative, with regular reviews and updates to reflect changes in the threat landscape, technology, and regulatory environment. This structured approach ensures that risk management is proactive rather than reactive, safeguarding the organization's assets and reputation. Question 6. The performance metrics show a consistent increase in call setup latency and a higher than acceptable rate of dropped video streams across the IP telephony and video network. Option A. Conduct a comprehensive risk assessment to identify potential causes of the performance degradation, evaluate their likelihood and impact, and prioritize mitigation strategies based on the findings. Option B. Focus solely on optimizing the bandwidth allocation for video streams, as this is the most resource-intensive component. Option C. Immediately initiate a full network-wide hardware refresh for all IP phones and video conferencing units to address potential equipment obsolescence. Option D. Ignore the performance metrics, assuming they are temporary fluctuations that will resolve themselves without intervention. The correct answer is A. Conduct a comprehensive risk assessment to identify potential causes of the performance degradation, evaluate their likelihood and impact, and prioritize mitigation strategies based on the findings. Explanation. This scenario presents a professional challenge due to the inherent conflict between maintaining optimal IP telephony and video service performance and adhering to the regulatory framework governing such deployments. The challenge lies in interpreting performance metrics that indicate potential issues, and then selecting a risk assessment approach that aligns with the specific requirements of the 300-070 CIPTV1 exam's implied jurisdiction, which we will assume for this context is a general framework applicable to IT service delivery without specific country-based regulations unless explicitly stated. The core difficulty is ensuring that any remediation or mitigation strategy is not only technically sound, but also justifiable within a risk management context that prioritizes service availability and integrity, as implicitly expected by regulatory bodies overseeing critical communication infrastructure. The correct approach involves a proactive and systematic risk assessment that prioritizes identified performance deviations based on their potential impact on service continuity and user experience. This aligns with best professional practice by ensuring that resources are allocated efficiently to address the most critical threats first. By focusing on the likelihood and impact of identified performance issues, a structured risk assessment allows for informed decision-making regarding mitigation strategies, such as configuration adjustments, hardware upgrades, or network optimizations. This approach is ethically sound as it aims to prevent service degradation and potential disruptions, thereby safeguarding the interests of users and the organization. It implicitly adheres to the spirit of regulatory compliance by demonstrating due diligence in maintaining a robust and reliable communication system. An incorrect approach would be to ignore the performance metrics altogether, assuming they are transient anomalies. This represents a significant regulatory and ethical failure, because it demonstrates a lack of due diligence in monitoring and maintaining critical IT infrastructure. Such inaction could lead to service outages, data breaches, or other security incidents, which would likely violate implicit regulatory expectations for service providers. Another incorrect approach is to immediately implement costly and potentially disruptive changes without a proper risk assessment. This is professionally unsound as it wastes resources, could introduce new problems, and fails to demonstrate a reasoned, evidence-based decision-making process. It suggests a reactive rather than a proactive stance, which is often viewed unfavorably in regulated environments. Finally, focusing solely on technical fixes without considering the business impact or user experience is also an incomplete approach. While technically sound, it may not address the root cause of the risk or provide the most effective solution from a holistic perspective, potentially leading to a recurrence of issues or dissatisfaction. The professional decision-making process for similar situations should involve a clear understanding of the service-level agreements, SLAs, and any relevant compliance mandates. When performance metrics indicate deviation, the first step is to gather and analyze the data to understand the nature and extent of the problem. This is followed by a structured risk assessment that considers the probability of the issue escalating and the potential impact on business operations and users. Based on this assessment, a prioritized list of mitigation strategies can be developed, evaluated for feasibility and cost-effectiveness, and then implemented. Continuous monitoring and re-evaluation of the risk landscape are crucial to ensure ongoing compliance and service quality. Question 7. Cost-benefit analysis shows that implementing a new feature for enhanced video conferencing quality offers significant perceived user experience improvements, but a recent security audit identified a low likelihood, medium-impact vulnerability in the underlying protocol that could potentially be exploited to disrupt service. The cost of patching the vulnerability is moderate, but the perceived immediate benefit of the new feature is high. Which approach best aligns with professional best practices and regulatory considerations for implementing this feature? Option A. Delay the feature implementation indefinitely until a completely vulnerability-free version of the protocol is available, prioritizing absolute security over immediate user experience enhancements. Option B. Conduct a comprehensive risk assessment to evaluate the potential impact of the vulnerability on service availability, data integrity, and regulatory compliance, and implement the patch before or concurrently with the feature rollout. Option C. Proceed with the feature implementation immediately, deferring the patch until a later, less critical maintenance window, as the user experience benefit outweighs the low likelihood risk. Option D. Implement the feature and the patch simultaneously, accepting the moderate cost of the patch as unnecessary overhead for the significant user experience gains. Correct answer is C. Proceed with the feature implementation immediately, deferring the patch until a later, less critical maintenance window, as the user experience benefit outweighs the low likelihood risk. Explanation. This scenario presents a professional challenge in balancing the perceived benefits of a new IP telephony feature against the potential risks and regulatory compliance requirements. The challenge lies in the subjective nature of improved user experience and the difficulty in quantifying the exact impact of a security vulnerability on that experience, especially when it's a potential rather than an active exploit. Careful judgment is required to avoid overinvesting in features with marginal benefits or underinvesting in security that could lead to significant downstream costs and regulatory penalties. The correct approach represents best professional practice because it prioritizes a thorough risk assessment that considers the specific regulatory framework applicable to Cisco IP telephony and video implementations. In the U.S., this would involve adherence to regulations like those from the FCC e.g. E911 requirements, data privacy, and potentially NIST guidelines for cybersecurity. A comprehensive risk assessment, including a detailed analysis of the potential impact of the identified vulnerability on service availability, data confidentiality, and integrity, is crucial. This aligns with the ethical obligation to provide secure and reliable communication services and the regulatory requirement to protect user data and ensure service continuity. By proactively addressing the vulnerability, the organization demonstrates due diligence and a commitment to mitigating potential harm, which is a cornerstone of responsible technology deployment. An incorrect approach that focuses solely on the immediate cost savings of not implementing a patch without a thorough risk assessment represents a significant regulatory and ethical failure. This approach ignores the potential for the vulnerability to be exploited, leading to service disruptions, data breaches, or even non-compliance with regulations such as HIPAA, if healthcare data is transmitted, or specific FCC mandates. The ethical failure lies in prioritizing short-term financial gain over the security and privacy of users. Another incorrect approach, which involves implementing the feature without any security review, is equally problematic. This demonstrates a disregard for established security best practices and regulatory expectations, potentially exposing the organization to significant liability and reputational damage. It fails to acknowledge that new features can introduce new attack vectors. A third incorrect approach, which relies on anecdotal evidence of user satisfaction without a structured risk assessment, is also flawed. While user experience is important, it cannot be the sole determinant when security vulnerabilities are present. This approach lacks the rigor required to make informed decisions about risk and compliance, potentially leading to a false sense of security. The professional decision-making process for similar situations should involve a structured risk management framework. This begins with identifying potential threats and vulnerabilities, assessing their likelihood and impact, and then evaluating mitigation strategies. For IP telephony systems, this includes considering regulatory requirements, potential financial losses, reputational damage, and the impact on user trust. Decisions should be data-driven, informed by technical expertise, and aligned with organizational policies and regulatory obligations. A proactive approach to security and compliance, rather than a reactive one, is always the most professional and responsible choice. Question 8. Compliance review shows that a large enterprise is planning to implement a new Cisco IP telephony system across its US-based facilities. The project team is focused on technical integration and user adoption. What is the most critical aspect of the impact assessment to ensure adherence to U.S. telecommunications regulations? Option A. Evaluating the system's bandwidth requirements and ensuring compatibility with existing network infrastructure to optimize call quality. Option B. Verifying the system's capability to accurately transmit caller location information to emergency services and assessing potential impacts on service availability during the transition. Option C. Confirming that the IP telephony vendor's proposed solution meets the latest industry best practices for network security and data encryption. Option D. Analyzing the potential for cost savings through reduced maintenance and operational expenses compared to the legacy system. The correct answer is B. Verifying the system's capability to accurately transmit caller location information to emergency services and assessing potential impacts on service availability during the transition. Explanation. Scenario analysis. This scenario presents a common challenge in IT deployments where a new technology, IP telephony, is being introduced. A professional challenge lies in ensuring that the implementation adheres to the specific regulatory framework governing telecommunications in the United States, as mandated by the 300-070 CIPTV1 exams jurisdiction. The impact assessment phase is critical because it requires foreseeing potential disruptions and ensuring compliance with regulations that protect user privacy, service availability, and emergency services access. Failure to conduct a thorough impact assessment can lead to significant legal penalties, service degradation, and reputational damage. Correct approach analysis. The correct approach involves a comprehensive assessment that specifically evaluates the impact of the IP telephony deployment on existing emergency services, like 911, and ensures compliance with the FCC's E911 mandate. This includes verifying that the system can accurately transmit the caller's location to emergency responders, a fundamental regulatory requirement in the U.S. It also necessitates understanding how the new system might affect the availability and reliability of critical communication services, aligning with general FCC guidelines on service continuity. This proactive approach minimizes risks and ensures adherence to established U.S. telecommunications law. Incorrect approaches analysis, focusing solely on the technical performance metrics of the IP telephony system, such as call quality and latency, without considering regulatory implications, represents a significant failure. While technical performance is important, it does not address the legal obligations related to emergency services or service availability. This approach risks noncompliance with FCC mandates, prioritizing cost savings and faster deployment over a detailed regulatory impact study is another failure. While efficiency is desirable, it cannot supersede legal requirements. The potential fines and remediation costs associated with regulatory noncompliance far outweigh any short-term savings. This approach demonstrates a disregard for established U.S. telecommunications law. Implementing the system based on vendor recommendations without independent verification of compliance with U.S. regulations is also professionally unsound. Vendors may not be fully aware of or prioritize specific U.S. regulatory nuances. Relying solely on vendor assurances without due diligence can lead to overlooking critical compliance gaps, such as accurate E911 location data transmission, which is a direct violation of FCC requirements. Professional reasoning. Professionals should adopt a risk-based approach to impact assessment, prioritizing regulatory compliance as a foundational element of any IT deployment. This involves 1. Identifying all applicable U.S. federal and state telecommunications regulations. 2. Engaging legal and compliance experts early in the project lifecycle. 3. Developing a detailed checklist of regulatory requirements to be verified during the impact assessment. 4. Documenting all assessment findings and mitigation strategies thoroughly. 5. Obtaining formal sign-off from compliance and legal teams before proceeding with deployment. This structured process ensures that technical implementation is aligned with legal and ethical obligations, safeguarding the organization and its users. Question 9. The audit findings indicate intermittent call quality degradation on the IP telephony network, with reports of dropped calls and garbled audio. The primary network infrastructure supporting the IP phones has been recently updated with new CO-S policies. The audit team has flagged potential misconfigurations in the CO-S implementation as a contributing factor. Which of the following approaches best addresses the audit findings and ensures a robust, compliant IP telephony environment? Option A. Immediately revert the CoS policies to their previous configuration to restore call quality, and then schedule a separate review of the new CoS implementation. Option B. Instruct the help desk to advise users experiencing issues to restart their IP phones, as this often resolves temporary network glitches. Option C. Implement additional bandwidth on the affected network segments without verifying the existing CoS configuration or its impact on other services. Option D. Conduct a thorough review of the new CoS policies and their implementation, comparing them against Cisco best practices for IP telephony CoS and the organization's security guidelines, before making any adjustments. The correct answer is A. Immediately revert the CoS policies to their previous configuration to restore call quality, and then schedule a separate review of the new CoS implementation. Explanation. This scenario presents a common challenge in network infrastructure management, balancing immediate operational needs with long-term security and compliance requirements. The professional challenge lies in identifying the root cause of the intermittent call quality issues and implementing a solution that is both effective and adheres to the established security policies and best practices for IP telephony deployments, as mandated by the Cisco CIPTV1 exam scope. A hasty or incomplete resolution could lead to recurring problems, security vulnerabilities, or noncompliance. The correct approach represents best professional practice because it prioritizes a systematic, evidence-based troubleshooting methodology by first verifying the network infrastructure's health and configuration against established baselines and security policies. It ensures that any proposed changes are well-informed and unlikely to introduce new issues or violate compliance. This aligns with the principles of robust network design and secure implementation, which are core to the CIPTV1 curriculum. It demonstrates a commitment to understanding the underlying causes rather than just addressing symptoms, leading to a more stable and secure IP telephony environment. An incorrect approach that bypasses proper verification and directly implements a configuration change without understanding the root cause is professionally unacceptable. This could lead to unintended consequences, such as disrupting other network services, creating security loopholes, or failing to resolve the actual problem, thus wasting resources and potentially violating operational integrity. Another incorrect approach that involves making changes without proper documentation or change control procedures is a direct contravention of IT best practices and can lead to an unmanageable network state, making future troubleshooting and auditing extremely difficult and increasing the risk of security breaches. Implementing a solution that is not aligned with the organization's security policies, even if it temporarily resolves the issue, represents a significant regulatory and ethical failure, as it undermines the organization's security posture and compliance obligations. The professional reasoning process should involve a structured approach to problem solving. This includes clearly defining the problem, gathering relevant data, logs, performance metrics, configuration details, forming hypotheses, testing those hypotheses systematically, and documenting all findings and actions. When troubleshooting IP telephony, it's crucial to consider the entire call path, including endpoints, network devices, and call processing elements, and to always operate within the established security and change management frameworks. Question 10. Benchmark analysis indicates that the current IP telephony and video deployment process is experiencing significant delays and cost overruns. To address this, a proposal suggests implementing a new automated provisioning system that promises to reduce deployment times by 50% and cut associated labor costs by 30%. However, this system has not been extensively tested in a live production environment, and its integration with existing security protocols is still under review. Which of the following approaches best balances the need for process optimization with the imperative to maintain service integrity and regulatory compliance? Option A. Implement the new automated provisioning system immediately across all new deployments to realize the projected cost and time savings, and address any integration issues as they arise. Option B. Prioritize cost reduction by adopting the new automated provisioning system with minimal integration testing, focusing solely on the projected financial benefits, and assuming that any security or compliance issues can be retroactively addressed. Option C. Conduct a pilot deployment of the new automated provisioning system in a limited, non-critical segment of the network, followed by a phased rollout to other segments based on successful validation and performance metrics. Option D. Defer the implementation of the new automated provisioning system indefinitely until a fully mature, enterprise-grade solution with guaranteed security and compliance certifications is available, even if it means continuing with the current inefficient processes. The correct answer is A. Implement the new automated provisioning system immediately across all new deployments to realize the projected cost and time savings, and address any integration issues as they arise. Explanation. This scenario presents a professional challenge in optimizing IP telephony and video deployment processes within the constraints of the 300-070 CIPTV1 exam's regulatory framework. The core difficulty lies in balancing the drive for efficiency and cost reduction with the imperative to maintain service quality, security, and compliance with relevant telecommunications regulations. A key aspect of process optimization in this context is ensuring that changes do not inadvertently introduce vulnerabilities or degrade the user experience, which could lead to regulatory scrutiny or customer dissatisfaction. The correct approach emphasizes a phased, controlled rollout of optimized processes, incorporating rigorous testing and validation at each stage. This aligns with best professional practices by minimizing risk and ensuring that any optimizations are thoroughly vetted before full implementation. Regulatory compliance is maintained by ensuring that all changes adhere to established standards for network performance, security, and data privacy, as implicitly required by the scope of implementing IP telephony and video solutions. This methodical approach allows for early detection of issues and facilitates adjustments without disrupting existing services or violating any implicit service level agreements or regulatory mandates concerning service availability and quality. Incorrect approaches fail to adequately address the inherent risks associated with process optimization in a critical infrastructure like IP telephony. One incorrect approach might involve a rapid, large-scale deployment of unproven optimizations without sufficient testing. This poses a significant regulatory and ethical risk by potentially causing widespread service disruption, compromising security, or failing to meet performance benchmarks that might be implicitly or explicitly governed by telecommunications regulations. Another incorrect approach could be to prioritize cost savings above all else, leading to the adoption of solutions that might be cheaper but lack the necessary robustness, security, or scalability, thereby risking noncompliance with service quality standards and potentially exposing the organization to penalties or reputational damage. A third incorrect approach might involve neglecting user feedback or impact assessments, which, while not a direct regulatory violation, can lead to operational inefficiencies and user dissatisfaction, indirectly impacting the perceived quality of service and potentially leading to complaints that could trigger regulatory review. Professionals should adopt a decision-making framework that prioritizes a risk-based approach to process optimization. This involves identifying potential risks, assessing their impact, and developing mitigation strategies. Thorough planning, phased implementation, continuous monitoring, and a commitment to iterative improvement are crucial. Professionals must also stay abreast of relevant regulations and industry best practices to ensure that optimization efforts remain compliant and ethically sound, always considering the impact on service availability, security, and user experience. Question 11. The monitoring system demonstrates a pattern of intermittent audio degradation reported by users in a specific branch office, characterized by choppy audio and occasional dropped calls, while other branches report normal call quality. Option A. Escalate the issue to the IP telephony vendor support team, providing them with the user reports of choppy audio and dropped calls. Option B. Analyze call detail records, CDR, for the affected branch office to identify call patterns, durations, and any associated error codes, and correlate this with network performance metrics such as jitter, packet loss, and latency on the WAN link and internal network segments serving that office. Option C. Immediately reboot all IP phones and network switches at the affected branch office to clear any potential temporary glitches. Option D. Randomly adjust the codec configurations on the IP phones and voice gateways serving the branch office to see if a different codec resolves the audio issues. The correct answer is B. Analyze call detail records, CDR, for the affected branch office to identify call patterns, durations, and any associated error codes, and correlate this with network performance metrics such as jitter, packet loss, and latency on the WAN link and internal network segments serving that office. Explanation: this scenario presents a common challenge in IP telephony deployments, ensuring consistent and reliable call quality across a distributed network. The professional challenge lies in identifying the root cause of intermittent audio degradation without disrupting ongoing services or making assumptions that could lead to incorrect troubleshooting and wasted resources. A systematic, data-driven approach is crucial, aligning with best practices for network management and service delivery. The correct approach represents best professional practice because it prioritizes objective data analysis and adherence to established quality of service (QoS) principles. Examining call detail records (CDR) and network performance metrics, engineers can pinpoint specific points of failure or congestion. This aligns with the implicit regulatory expectation of providing a reliable and functional service to end users, which is a fundamental aspect of telecommunications provision. Furthermore, a methodical approach minimizes the risk of introducing new problems while troubleshooting, thereby upholding service continuity. An incorrect approach that focuses solely on endpoint reboots fails to address potential network-level issues. This is professionally unacceptable as it ignores the possibility that the problem lies upstream, such as in routers, switches, or WAN links. Ethically, it represents a failure to diligently investigate the problem, potentially leading to prolonged service degradation for users. Another incorrect approach that involves randomly adjusting codec settings without understanding the impact on bandwidth and processing power is also professionally unsound. This can lead to unintended consequences, such as increased latency or dropped calls, exacerbating the original problem. It demonstrates a lack of systematic troubleshooting and a disregard for the interconnected nature of IP telephony components. A third incorrect approach that involves immediately escalating the issue to a vendor without performing initial diagnostics is premature and inefficient. While vendor support is valuable, it should be leveraged after internal troubleshooting has identified specific areas of concern. This approach can lead to unnecessary delays and costs, and it fails to develop the internal expertise required for effective problem resolution. The professional reasoning process for similar situations should involve 1. Clearly defining the observed problem. 2. Gathering all relevant data, logs, performance metrics, user reports. 3. Forming hypotheses based on the data. 4. Testing hypotheses systematically. 5. Implementing solutions based on confirmed findings. And 6. Verifying the resolution. This structured approach ensures that troubleshooting is efficient, effective, and minimizes disruption. Question 12. The evaluation methodology shows that a proposed IP telephony deployment for a regulated financial institution requires a robust security posture and guaranteed call quality. The network administrator is considering several approaches to segment and secure the voice traffic. Which approach best aligns with the principles of secure network design and regulatory compliance for sensitive communications? Option A. Create separate physical networks for voice and data, but do not implement any QoS policies, assuming the physical separation is sufficient for security and performance. Option B. Implement a dedicated VLAN for voice traffic, but configure overly restrictive firewall rules that block all traffic not explicitly permitted by a strict whitelist, potentially impacting CUCM functionality. Option C. Implement a dedicated VLAN for voice traffic. Configure appropriate quality of service (QoS) policies to prioritize voice packets and ensure firewall rules permit necessary CUCM signaling and media ports. Option D. Route all voice traffic over the existing data network without any specific segmentation or QoS, relying solely on endpoint security features. Correct answer is C. Implement a dedicated VLAN for voice traffic. Configure appropriate quality of service (QoS) policies to prioritize voice packets and ensure firewall rules permit necessary CUCM signaling and media ports. Explanation: this scenario presents a common challenge in network design and implementation, balancing the need for robust security with the operational requirements of a modern IP telephony system. The professional challenge lies in understanding the specific security implications of different network segmentation strategies and their impact on the Cisco Unified Communications Manager (CUCM) infrastructure, particularly concerning the regulatory framework governing data privacy and network integrity. The correct approach, which involves segmenting the voice traffic onto a dedicated VLAN and implementing appropriate quality of service COS policies, represents best professional practice. This is because it directly addresses the security and performance requirements mandated by the regulatory framework for sensitive communication data. By isolating voice traffic, it minimizes the attack surface for potential threats targeting the voice network, thereby enhancing data confidentiality and integrity. Furthermore, the implementation of COS ensures that voice traffic receives the necessary priority, guaranteeing the availability and reliability of critical communication services, a key tenet of regulatory compliance for essential services. This approach aligns with the principle of least privilege and defense in depth, fundamental security concepts often implicitly or explicitly required by regulatory bodies concerned with the secure handling of telecommunications. An incorrect approach that bypasses VLAN segmentation and COS for voice traffic would represent a significant regulatory and ethical failure. Such an approach would expose the voice network to the same security risks as general data traffic, potentially leading to unauthorized access, eavesdropping, or denial of service attacks. This directly contravenes regulations that mandate the protection of sensitive communication data and the assurance of service availability. Ethically, it demonstrates a disregard for the security and privacy of users relying on the IP telephony system. Another incorrect approach, such as implementing overly restrictive firewall rules that inadvertently block essential CUCM signaling or media ports, would also be a regulatory and ethical failure. While security is paramount, blocking legitimate traffic disrupts service availability, which is a critical compliance requirement. This demonstrates a lack of understanding of the specific port requirements for Cisco IP telephony, leading to a failure to meet the availability and reliability mandates. A third incorrect approach, like relying solely on endpoint encryption without network-level segmentation, would be insufficient. While endpoint encryption is a valuable security layer, it does not address network-level threats or the need for traffic prioritization. This approach fails to meet the comprehensive security and performance requirements, potentially leaving the system vulnerable to network-based attacks and performance degradation, thus failing to adhere to the spirit and letter of regulations requiring robust protection and reliable service. The professional decision-making process for similar situations should involve a thorough understanding of the Cisco Unified Communications Manager, CUCM, architecture, the specific security and performance requirements dictated by the relevant regulatory framework, and the capabilities of Cisco networking technologies. This includes performing a risk assessment, identifying critical assets and potential threats, and designing a solution that implements a layered security approach, incorporating network segmentation, access control, and COS, while ensuring compliance with all applicable regulations. Question 13. The efficiency study reveals that the enterprise's Cisco Unified Communications Manager, CUCM, call routing is experiencing intermittent failures and increased latency during peak hours. Which of the following diagnostic and optimization strategies best addresses these issues while adhering to best practices for IP telephony implementation? Option A. Immediately increase the bandwidth of all network links supporting voice traffic and implement aggressive quality of service, COS, policies across the entire network infrastructure. Option B. Analyze and optimize the CUCM dial plan, route patterns, route lists, and route groups, ensuring efficient call routing logic and adequate resource allocation for gateways and trunks, while also reviewing call admission control (CAC) settings. Option C. Reconfigure all voicemail integration settings and disable any advanced call features like hunt groups and call forwarding to simplify the system. Option D. Focus solely on upgrading the CUCM server hardware to the latest generation, without investigating the existing call routing configuration or network performance. The correct answer is B. Analyze and optimize the CUCM dial plan, route patterns, route lists, and route groups, ensuring efficient call routing logic and adequate resource allocation for gateways and trunks, while also reviewing call admission control (CAC) settings. Explanation. The efficiency study reveals that the current implementation of Cisco Unified Communications Manager, CUCM, for call routing within a mid-sized enterprise is experiencing intermittent call setup failures and increased latency, particularly during peak hours. The IT department is tasked with optimizing this system to meet service level agreements, SLAs, for call quality and availability. This scenario is professionally challenging because it directly impacts business operations and customer satisfaction. The IT team must balance technical feasibility, cost-effectiveness, and adherence to Cisco's recommended best practices for CUCM deployment and configuration to ensure a robust and reliable voice and video communication infrastructure. The correct approach involves a systematic and data-driven evaluation of the CUCM call routing configuration, focusing on key parameters that influence performance and reliability. This includes analyzing dial plan complexity, route patterns, route lists, route groups, and the configuration of gateways and trunk resources. Best professional practice dictates a thorough understanding of how these components interact and how to optimize them for the specific traffic patterns and call volume of the organization. This ensures that calls are routed efficiently and reliably, minimizing setup failures and latency, thereby meeting or exceeding established SLAs. Adherence to Cisco's design guides and best practices for CUCM is paramount, as these are developed based on extensive testing and real-world deployments. An incorrect approach would be to make broad, unverified changes to the CUCM configuration without a clear understanding of the root cause. For example, indiscriminately increasing gateway resources without analyzing call admission control, CAC, settings, or the actual utilization of existing resources could lead to unnecessary expenditure and potentially introduce new issues. Another incorrect approach would be to solely focus on network-level troubleshooting, e.g., COS, without considering the internal call routing logic within CUCM. While network performance is critical, inefficient call routing configurations can exacerbate network issues or even be the primary cause of call failures. Furthermore, ignoring the impact of specific call routing features, such as hunt groups or call forwarding, on overall system load and performance would be a significant oversight. These approaches fail to address the core problem systematically and risk creating more complex issues, potentially violating implicit ethical obligations to provide a functional and reliable service. The professional decision-making process should involve 1. Clearly defining the problem and its impact. 2. Gathering relevant data, called detail records, system logs, performance metrics. 3. Hypothesizing potential causes based on the data and knowledge of CUCM call routing. 4. Testing hypotheses in a controlled environment or with phased rollouts. 5. Implementing solutions based on validated findings. And 6. Monitoring the system post-implementation to confirm resolution and identify any new issues. This iterative process ensures that solutions are targeted, effective, and minimize disruption. Question 14. Stakeholder feedback indicates a need to upgrade the IP telephony system to support new video conferencing features. However, the organization operates in a jurisdiction where telecommunications regulations mandate continuous availability of emergency calling services, e.g., 911/999/112. The upgrade involves significant changes to the core call processing and signaling infrastructure. What is the most professionally responsible approach to implement this upgrade while strictly adhering to the regulatory framework? Option A. Execute the upgrade during peak business hours to minimize disruption to non-critical services, relying on the inherent redundancy of the IP telephony system to maintain emergency calling availability. Option B. Prioritize meeting the aggressive project deadline by skipping comprehensive end-to-end testing and relying on vendor support for immediate issue resolution post-implementation, with stakeholder consent for the expedited timeline. Option C. Implement the upgrade in phases, starting with non-critical services, conducting thorough testing in a lab environment that mirrors production, and establishing a detailed rollback plan for each phase. Option D. Perform a complete system cutover during a scheduled maintenance window, informing stakeholders of the potential for brief service interruptions, but proceeding with the full upgrade at once to minimize the overall project duration. The correct answer is C. Implement the upgrade in phases, starting with non-critical services, conducting thorough testing in a lab environment that mirrors production, and establishing a detailed rollback plan for each phase. Explanation. This scenario presents a common implementation challenge in IP telephony, ensuring that critical communication services remain available and compliant with regulatory requirements during a planned network upgrade. The challenge lies in balancing the need for technological advancement with the absolute priority of maintaining uninterrupted service, especially for emergency communications, which are often subject to stringent regulatory oversight. Professional judgment is required to select an upgrade strategy that minimizes risk and adheres to all applicable regulations. The correct approach prioritizes a phased rollout with robust fallback mechanisms and thorough testing. This represents best professional practice because it directly addresses the regulatory mandate for service continuity and reliability, particularly for emergency services. By isolating changes, testing thoroughly in a controlled environment, and having a clear rollback plan, the implementation minimizes the risk of service disruption. This proactive approach aligns with the ethical responsibility to ensure that critical communication infrastructure remains functional and compliant with all relevant telecommunications regulations, which typically mandate high availability for emergency calling services. An incorrect approach that involves a big bang cutover without adequate testing or fallback is professionally unacceptable. This strategy carries an unacceptably high risk of widespread service disruption, which would be a direct violation of regulatory requirements for service availability and reliability. Such a failure could lead to significant penalties, reputational damage, and, most importantly, compromise public safety by disrupting access to emergency services. Another incorrect approach, performing the upgrade during peak business hours without a rollback plan, demonstrates a severe lack of risk assessment and adherence to professional standards. This not only increases the likelihood of service interruption, but also ignores the potential impact on business operations, which is a key stakeholder concern. Ethically, it shows a disregard for the operational continuity of the organization and its users. Finally, an approach that bypasses thorough testing to meet an aggressive deadline, even with stakeholder awareness, is also professionally flawed. While stakeholders may be informed, the responsibility to ensure a compliant and functional system ultimately rests with the implementation team. Ignoring critical testing phases, even with consent, can lead to unforeseen issues that violate regulatory standards for service quality and reliability, and it fails to uphold the professional duty to deliver a robust and dependable solution. The professional decision-making process for similar situations should involve a comprehensive risk assessment, a thorough understanding of all applicable regulatory requirements, and the development of a phased implementation plan with clear testing and rollback procedures. Prioritizing service continuity, especially for critical services, should be the paramount consideration. Engaging with stakeholders to manage expectations and communicate risks is important, but it does not absolve the implementation team of its responsibility to ensure regulatory compliance and operational integrity. Question 15. The monitoring system demonstrates intermittent packet loss and increased latency on the core network segment that supports IP telephony services following a recent network infrastructure upgrade. The upgrade involved replacing older switches with newer models and reconfiguring routing protocols. The goal was to improve overall network performance and capacity. What is the most professional and effective approach to address this situation? Option A. Immediately roll back all network infrastructure changes to the previous configuration and initiate a detailed post-mortem analysis. Option B. Perform a full rollback of all network infrastructure changes during the next scheduled maintenance window, as the current issues are impacting user experience. Option C. Proceed with the upgrade as planned, assuming the monitoring anomalies are transient and will resolve themselves with time. Option D. Implement a phased rollback of the new switches and routing configurations, testing voice service functionality after each phase, and conducting targeted diagnostics on the affected segment. The correct answer is A. Immediately roll back all network infrastructure changes to the previous configuration and initiate a detailed post-mortem analysis. Explanation: scenario analysis. This scenario presents a common implementation challenge in IP telephony, ensuring seamless call continuity and user experience during network changes. The professional challenge lies in balancing the need for network upgrades with the critical requirement of maintaining uninterrupted voice services, which are often essential for business operations and regulatory compliance. The complexity arises from the interconnected nature of voice traffic, its sensitivity to latency and jitter, and the potential for significant disruption if not managed meticulously. Careful judgment is required to select an implementation strategy that minimizes risk while achieving the desired network improvements. Correct approach analysis. The correct approach involves a phased rollout with rigorous testing at each stage. This aligns with best professional practices for network changes, particularly those impacting real-time services like voice. By implementing changes incrementally and validating functionality after each phase, engineers can isolate and address any issues before they affect a larger user base. This methodical approach minimizes the blast radius of potential problems. From a regulatory and ethical standpoint, this demonstrates a commitment to service continuity and user welfare, which are implicit in many telecommunications regulations that mandate reliable service delivery. It also aligns with the principle of due diligence in network management, ensuring that changes are implemented responsibly. Incorrect approaches analysis. Implementing all changes simultaneously without intermediate testing is a high-risk strategy. It fails to adhere to professional best practices for network change management, as it offers no mechanism for isolating or troubleshooting issues. If a problem arises, it becomes extremely difficult to pinpoint the cause, leading to prolonged service outages. This approach could also have regulatory implications if it results in a significant and unmanaged disruption of essential communication services, potentially violating service-level agreements or regulatory mandates for service availability. Rolling back all changes immediately upon detecting any minor anomaly, without further investigation or phased testing, is also professionally unsound. A caution is important. An immediate and complete rollback without understanding the root cause can be inefficient and may unnecessarily delay necessary network upgrades. It suggests a lack of confidence in the testing methodology or an inability to perform effective root cause analysis. Ethically, it might be seen as an overreaction that prioritizes avoiding any perceived risk over achieving necessary improvements, potentially impacting business efficiency. Implementing changes during peak business hours without a clear rollback plan is a direct violation of professional network management principles and carries significant regulatory and ethical risks. Peak hours are when service disruption has the most severe impact on business operations. The absence of a rollback plan indicates a failure to anticipate potential problems and a lack of preparedness, which is unprofessional and could lead to extended outages. This approach demonstrates a disregard for service continuity and could lead to breaches of service-level agreements and potential regulatory penalties for failing to provide reliable service. Professional reasoning. Professionals should adopt a risk-based, phased approach to network changes. This involves detailed planning, including defining clear objectives, identifying potential risks, and developing mitigation strategies. Before any implementation, a thorough understanding of the existing environment and the impact of the proposed changes is crucial. During implementation, a staged rollout, coupled with comprehensive testing and validation at each stage, is paramount. This allows for early detection and resolution of issues, minimizing disruption. A well-defined rollback plan should always be in place, outlining the steps to revert to the previous state if critical issues arise. Continuous monitoring and communication with stakeholders throughout the process are also essential for effective management and to maintain trust. Question 16. Operational review demonstrates that the current IP telephony system is nearing end of life, necessitating an upgrade to a new Cisco IP telephony solution. The organization operates under strict telecommunications regulations that mandate service continuity and data security. The implementation team is considering several approaches for deploying the new system. Which approach best aligns with professional best practices and regulatory expectations for such a critical infrastructure upgrade? Option A. Execute a Big Bang deployment, switching all users to the new system simultaneously over a single weekend to minimize disruption during business hours. Option B. Implement the new Cisco IP telephony solution in a phased rollout, starting with a pilot deployment in a non-critical department, followed by iterative expansion based on successful testing and user feedback. Option C. Deploy the new Cisco IP telephony solution immediately across all departments, addressing any security concerns or user issues as they arise post-implementation. Option D. Prioritize the technical features of the new Cisco IP telephony solution and deploy it as quickly as possible, deferring comprehensive security audits and user training until after the system is fully operational. The correct answer is B. Implement the new Cisco IP telephony solution in a phased rollout, starting with a pilot deployment in a non-critical department, followed by iterative expansion based on successful testing and user feedback. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent complexity of integrating new IP telephony services with existing infrastructure while ensuring compliance with established regulatory frameworks. The challenge lies in balancing the technical requirements of the implementation with the need to maintain service continuity and adhere to specific operational guidelines that govern telecommunications deployments. A hasty or incomplete approach can lead to service disruptions, security vulnerabilities, and non-compliance, all of which carry significant professional and organizational repercussions. Careful judgment is required to select an implementation strategy that is both technically sound and legally/operationally defensible. Correct approach analysis. The correct approach emphasizes a phased rollout strategy, beginning with a pilot deployment in a controlled environment. This aligns with best professional practices for implementing new technologies in a regulated industry. It allows for thorough testing and validation of the IP telephony solution's functionality, performance, and interoperability with existing systems before a full-scale deployment. This iterative process enables the identification and remediation of potential issues in a low-risk setting, minimizing the impact on the broader user base. Furthermore, this approach facilitates the collection of performance data and user feedback, which are crucial for refining the deployment plan and ensuring that the final implementation meets all technical and operational requirements. This methodical approach is consistent with the principles of responsible technology adoption and risk management, which are implicitly expected within regulated environments. Incorrect approaches analysis. A Big Bang deployment, where all changes are implemented simultaneously across the entire organization, represents a significant regulatory and ethical failure. This approach introduces an unacceptably high risk of widespread service disruption, which can have severe consequences for business operations and potentially violate service-level agreements or regulatory mandates regarding service availability. It also bypasses the opportunity for controlled testing and validation, increasing the likelihood of unforeseen technical problems going unnoticed until they impact a large number of users. Implementing the new IP telephony solution without a comprehensive security audit and the implementation of appropriate security measures is another critical failure. In the context of telecommunications, security is paramount. Failure to address security vulnerabilities before deployment can expose the network to unauthorized access, data breaches, and service manipulation, which are serious regulatory and ethical breaches. This negligence can lead to significant financial penalties and reputational damage. Deploying the solution without adequate user training and documentation is also professionally unacceptable. While not a direct regulatory violation in all jurisdictions, it demonstrates a lack of due diligence in ensuring the successful adoption and effective use of the new technology. This can lead to user frustration, decreased productivity, and an increase in support calls, ultimately undermining the intended benefits of the IP telephony implementation and reflecting poorly on the professional responsibility of the implementation team. Professional reasoning. Professionals tasked with implementing IP telephony solutions must adopt a structured and risk-aware approach. This involves a thorough understanding of the technology, the existing infrastructure, and the relevant regulatory landscape. The decision-making process should prioritize a phased implementation, starting with pilot programs, to mitigate risks and ensure successful integration. Continuous monitoring, testing, and validation are essential throughout the deployment lifecycle. Furthermore, a strong emphasis on security and user enablement, including comprehensive training and documentation, is critical for a responsible and effective implementation. This systematic approach ensures that technical objectives are met while upholding professional standards and regulatory compliance. Question 17. Process analysis reveals that a company is planning to deploy a new Cisco IP telephony solution across multiple US-based offices. The project timeline is aggressive, with significant pressure from executive leadership to go live within the next quarter. While the technical team is confident in their ability to integrate the Cisco Unified Communications Manager, CUCM, and Cisco Unity Connection, there is a perceived lack of urgency regarding the specific regulatory compliance aspects related to emergency services and accessibility, as these are often seen as secondary to core functionality. The project manager is seeking the most prudent approach to ensure the successful and compliant deployment of the new system. Option A. Focus solely on achieving the aggressive timeline by implementing the system with the assumption that existing network infrastructure already meets all necessary regulatory requirements for emergency services and accessibility. Option B. Proceed with the immediate deployment of core telephony features, prioritizing user experience and technical performance, and address any regulatory compliance gaps in a subsequent phase after the initial go-live. Option C. Delegate the responsibility for regulatory compliance to the IT support team post-deployment, allowing them to address any identified issues as they arise during routine operations. Option D. Conduct a comprehensive risk assessment and compliance audit against relevant U.S. FCC regulations, including E911 requirements and accessibility standards, before proceeding with full-scale implementation, and integrate compliance checkpoints throughout the project lifecycle. The correct answer is D. Conduct a comprehensive risk assessment and compliance audit against relevant U.S. FCC regulations, including E911 requirements and accessibility standards, before proceeding with full-scale implementation, and integrate compliance checkpoints throughout the project lifecycle. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent complexity of integrating new IP telephony services within an existing, potentially legacy, network infrastructure. The primary challenge lies in ensuring that the implementation not only meets technical requirements, but also adheres to the specific regulatory framework governing telecommunications services within the exam's jurisdiction. This jurisdiction, for the purpose of this exam, is assumed to be the United States, requiring compliance with relevant FCC, Federal Communications Commission, regulations and potentially state-level Public Utility Commission, PUC, guidelines concerning service availability, emergency services, like E911, and data privacy. The pressure to deploy quickly can lead to shortcuts that might compromise compliance, making careful judgment and a thorough understanding of regulatory obligations paramount. Correct approach analysis. The correct approach involves a phased implementation that prioritizes a comprehensive risk assessment and a detailed compliance audit against U.S. regulatory frameworks, specifically FCC rules regarding E911 services, number portability, and accessibility for individuals with disabilities. This approach represents best professional practice because it proactively identifies and mitigates potential regulatory violations before service deployment. By engaging with legal and compliance teams early, the project ensures that the new IP telephony system is designed and configured to meet all legal mandates, such as providing accurate location information for E911 calls and ensuring compliance with the Americans with Disabilities Act (ADA) for accessibility. This methodical process minimizes the risk of service disruption, fines, and reputational damage associated with noncompliance. Incorrect approaches analysis. Prioritizing immediate deployment of core telephony features without a thorough regulatory review is a significant ethical and regulatory failure. This approach risks noncompliance with critical FCC mandates, such as the CARI's Law and RAY-Baum's Act requirements for E911 location information, which could lead to severe penalties and endanger public safety. Focusing solely on technical performance metrics and user experience, while important, overlooks the legal obligations of a telecommunications service provider. This oversight can result in the deployment of a system that, while technically sound, fails to meet legal requirements for accessibility or emergency service provisioning, leading to regulatory sanctions. Implementing the system with a fix-it-later mentality regarding compliance issues is a direct abdication of professional responsibility. This reactive approach is ethically unsound as it knowingly deploys a potentially non-compliant service, exposing the organization to legal repercussions, and failing to uphold the public trust associated with telecommunications services. Professional reasoning. Professionals tasked with implementing IP telephony systems must adopt a risk-based, compliance-first mindset. The decision-making process should begin with a thorough understanding of the applicable regulatory landscape, in this case, U.S. FCC regulations. This involves proactive engagement with legal and compliance departments to identify all relevant mandates. A phased approach, incorporating compliance checks at each stage of design, implementation, and testing, is crucial. When faced with potential conflicts between rapid deployment and regulatory adherence, the professional must advocate for the latter, understanding that long-term operational stability and legal standing outweigh short-term deployment gains. Documenting all compliance efforts and decisions is also a critical component of professional due diligence. Question 18. Assessment of the most appropriate configuration strategy within Cisco Unified Communications Manager, CUCM, to ensure compliance with U.S. emergency services regulations when implementing a new IP telephony system, considering the need to prioritize emergency call delivery and accuracy. Option A. Implement a generic dial plan that supports all internal extensions and assume that the network infrastructure will automatically route emergency calls to the appropriate SAP without specific CUCM configuration. Option B. Configure CUCM to prioritize emergency call traffic with specific COS markings and ensure the dial plan accurately maps emergency numbers to the correct gateways for SAP connectivity, validating this configuration through simulated emergency calls. Option C. Focus solely on optimizing general call quality and bandwidth for all users, deferring any specific emergency call routing configurations until a potential issue arises. Option D. Configure CUCM with a dial plan that prioritizes high-bandwidth video conferencing traffic, with emergency calls being routed through the same general call processing as standard internal calls. The correct answer is B. Configure CUCM to prioritize emergency call traffic with specific COS markings and ensure the dial plan accurately maps emergency numbers to the correct gateways for SAP connectivity, validating this configuration through simulated emergency calls. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the implementation of Cisco IP telephony solutions within a regulated environment. The core difficulty lies in balancing the technical requirements of call routing and quality of service, COS, with the imperative to comply with specific regulatory mandates that govern telecommunications services. The need to ensure uninterrupted service for emergency calls, like 911 in the U.S., while also optimizing general call quality and managing network resources, creates a complex decision-making landscape. Failure to correctly configure call routing, especially for emergency services, can have severe legal and ethical consequences, including potential harm to individuals and significant penalties for the organization. Correct approach analysis. The correct approach prioritizes the regulatory requirement for emergency call routing by ensuring that the Cisco Unified Communications Manager, CUCM, is configured to correctly identify and route emergency calls to the appropriate public safety answering point, SAP, based on the caller's location. This involves leveraging features like location-based dial plan and E164 numbering plans to accurately map dialed emergency numbers to the correct gateway and ultimately the SAP. Furthermore, implementing COS policies that prioritize emergency call traffic ensures that these critical calls maintain a high level of quality, even under network congestion. This approach aligns with the regulatory framework by directly addressing the legal obligation to provide reliable emergency services, a cornerstone of telecommunications regulation in the U.S. It demonstrates best professional practice by proactively mitigating risks associated with emergency call failures and ensuring compliance with public safety mandates. Incorrect approaches analysis. One incorrect approach would be to solely focus on optimizing general call quality and network bandwidth utilization without explicitly configuring and testing emergency call routing. This fails to meet the fundamental regulatory requirement for emergency services, creating a significant legal and ethical liability. The organization would be in violation of regulations mandating the reliable delivery of emergency calls. Another incorrect approach would be to assume that default gateway configurations will automatically handle emergency calls correctly. This is a dangerous assumption, as emergency call routing is highly location-dependent and requires specific configuration within CUCM and the underlying network infrastructure to ensure calls are directed to the correct SAP. Relying on defaults would likely result in misrouted or failed emergency calls, leading to regulatory noncompliance and potential harm. A third incorrect approach would be to implement COS policies that prioritize general business traffic over emergency calls. While optimizing general call quality is important, emergency calls are a critical exception that must be given the highest priority to ensure their successful and clear transmission. This approach would violate the spirit and letter of regulations that emphasize the paramount importance of emergency communication. Professional reasoning. Professionals must adopt a risk-based decision-making process. This involves first identifying all regulatory requirements, particularly those related to public safety and emergency services. Then, technical solutions must be designed and implemented to meet these requirements as the absolute priority. Thorough testing and validation of emergency call routing and CO-S for emergency traffic are crucial. In situations where technical optimization might conflict with regulatory mandates, the regulatory requirement must always take precedence. Continuous monitoring and periodic review of configurations are essential to maintain compliance and ensure the ongoing reliability of critical communication services. Question 19. Comparative studies suggest that implementing secure and compliant call routing across geographically dispersed Cisco Unified Communications Manager (CUCM) clusters present significant technical and regulatory hurdles. Considering the need to protect sensitive call data and adhere to communication privacy mandates, which of the following implementation strategies best addresses these challenges for a multi-site deployment? Option A. Employ a VPN tunnel between the CUCM clusters for all traffic, but allow signaling and media to traverse this tunnel in clear text. Option B. Configure CUCM clusters to route all calls directly to each other without the use of cube devices, assuming that internal network traffic is inherently secure. Option C. Utilize unencrypted SIP signaling between CUCM clusters and route media directly between sites without additional encryption, relying on general network security measures. Option D. Implement SRTP for media encryption and TLS for signaling encryption between CUCM clusters and Cisco Unified Border Element (CUBE) devices, ensuring secure and authenticated communication channels. The correct answer is D. Implement SRTP for media encryption and TLS for signaling encryption between CUCM clusters and Cisco Unified Border Element (CUBE) devices, ensuring secure and authenticated communication channels. Explanation. Scenario analysis. This scenario presents a common implementation challenge in IP telephony, ensuring secure and compliant call routing in a multi-site environment. The professional challenge lies in balancing the technical requirements of call flow with the stringent regulatory obligations concerning data privacy and secure communication. Misinterpreting or overlooking these regulations can lead to significant legal repercussions, data breaches, and loss of trust. The need for a robust and compliant solution requires careful consideration of how call data, including potentially sensitive information, is handled and transmitted across different network segments. Correct approach analysis. The correct approach involves implementing a secure signaling protocol, such as SRTP for media and TLS for signaling, between the Cisco Unified Communications Manager (CUCM) clusters and the Cisco Unified Border Element (CUBE) devices. This ensures that call control messages and media streams are encrypted and authenticated, protecting them from eavesdropping and tampering. This aligns with general principles of data protection and secure communication, which are implicitly required by regulatory frameworks that mandate the confidentiality and integrity of communications. By encrypting signaling and media, the organization upholds its responsibility to protect user data and maintain the privacy of conversations, thereby adhering to the spirit of regulations that govern telecommunications and data handling. Incorrect approaches analysis. Using unencrypted signaling protocols like SIP without TLS exposes call control information to potential interception. This is a direct failure to implement adequate security measures for sensitive communication data, which could violate regulations requiring data confidentiality. Transmitting media streams without SRTP encryption means that voice and video data can be easily captured and understood by unauthorized parties, again contravening data privacy and security mandates. Routing all calls directly between CUCM clusters without a cube, even if encrypted, might bypass necessary security and compliance checks that a cube can provide, such as call admission control and lawful intercept capabilities, which are often mandated by regulatory bodies. Implementing a solution that relies solely on network-level security, like VPNs, without securing the signaling and media at the application layer is insufficient, as it doesn't guarantee end-to-end encryption of the communication content itself. Professional reasoning. Professionals must adopt a risk-based approach, prioritizing security and compliance from the outset of any IP telephony implementation. This involves understanding the specific regulatory landscape applicable to the organization's operating jurisdiction and designing solutions that proactively address these requirements, When faced with a multi-site deployment, the decision-making process should involve 1. Identifying all potential points of data transmission and storage. 2. Assessing the sensitivity of the data being transmitted. 3. Researching and applying relevant security protocols and best practices. 4. Consulting with legal and compliance teams to ensure adherence to all applicable regulations. 5. Documenting the security and compliance measures implemented. This systematic approach ensures that technical solutions are not only functional but also legally sound and ethically responsible. Question 20. Market research demonstrates that a significant portion of businesses are considering upgrades to their IP telephony and video infrastructure. You are a senior engineer working for a Cisco partner, currently engaged in a critical project for Client A, which involves implementing Cisco Unified Communications Manager, CUCM, and Cisco Telepresence Solutions. During a vendor conference, you are approached by a representative from Client B, a direct competitor of Client A, who expresses interest in your firm's services for a similar IP telephony and video upgrade project. Client B is aware of your firm's expertise and specifically requests your involvement, offering a lucrative contract. You recognize that Client A's project is nearing completion, and the new project with Client B could significantly boost your firm's revenue and your personal performance metrics. What is the most ethically sound and professionally responsible course of action? Option A. Immediately inform your direct manager and the firm's ethics officer about the potential conflict of interest and await their guidance on how to proceed, ensuring full transparency with both Client A and Client B regarding your firm's internal review process. Option B. Decline the opportunity from Client B immediately, citing a potential conflict of interest, without further consultation with your management or the client. Option C. Accept the lucrative contract from Client B and discreetly manage both projects, ensuring no proprietary information from Client A is shared with Client B. Option D. Proceed with the project for Client B, assuming that since Client A's project is nearing completion, there is no longer a significant conflict of interest. The correct answer is A. Immediately inform your direct manager and the firm's ethics officer about the potential conflict of interest and await their guidance on how to proceed, ensuring full transparency with both Client A and Client B regarding your firm's internal review process. Explanation. This scenario presents an ethical dilemma common in IT consulting, particularly when dealing with sensitive customer data and potential conflicts of interest. The challenge lies in balancing the consultant's duty to their current client with the potential for personal gain, while adhering to professional conduct and the specific regulatory framework governing Cisco IP telephony and video implementations in the United States. The correct approach prioritizes the current client's best interests and upholds professional integrity. By disclosing the potential conflict and seeking guidance from their employer, the consultant demonstrates transparency and adherence to ethical standards. This aligns with general principles of professional conduct that require consultants to avoid situations where their personal interests could compromise their professional judgment or the client's trust. Specifically, in the U.S., regulations and professional bodies often emphasize fiduciary duties and the avoidance of conflicts of interest, particularly when dealing with proprietary information or client relationships. The consultant's actions should be guided by the Cisco Partner Code of Conduct and any applicable U.S. federal or state laws regarding business ethics and data privacy. An incorrect approach would be to proceed with the new opportunity without full disclosure. This creates a direct conflict of interest. Ethically, it breaches the trust placed in the consultant by their current employer and client. From a regulatory standpoint, depending on the specifics of the data involved and the nature of the new opportunity, this could potentially violate U.S. laws related to unfair competition, breach of contract, or even data misuse if proprietary information from the current client is leveraged. Another incorrect approach would be to dismiss the new opportunity outright without proper consideration or consultation. While seemingly safe, this might mean missing a legitimate business opportunity for the consulting firm and could be seen as a failure to act in the best interest of the employer if the new opportunity is genuinely beneficial and manageable without ethical compromise. However, the primary ethical failure here is the lack of due diligence and communication. A third incorrect approach would be to accept the new opportunity and attempt to manage it secretly. This is a severe ethical breach. It involves deception, undermines the integrity of the consulting firm, and exposes both the consultant and the firm to significant legal and reputational risks. It directly violates principles of honesty and transparency and could lead to severe penalties under U.S. business law and professional codes of conduct. The professional decision-making process in such situations should involve 1. Identifying the potential conflict of interest. 2. Consulting internal company policies and ethical guidelines. 3. Seeking advice from management or legal counsel. 4. Prioritizing transparency and disclosure with all relevant parties. 5. Documenting all decisions and communications. 6. Acting in a manner that upholds professional integrity and protects client interests.